All right, the training wheels are off. There's no helps over here, but you know what to do. Find rate, given rate, equation, and when. All right, so let's get a picture going on here. A child's flying a kite, and the kite is at 300 feet above the ground. So child, kite. So this is 300 feet. Okay, and the wind is carrying the kite horizontally at 25 feet per second. So it's a perfect world, so it's just moving straight this way, and that looks like a rate that's given. So how about we give that the letter x, and we say dx over dt is 25. All right, so how fast must she let the string out? Or how fast is this getting let out when 500 feet of string has been let out? So how fast does this need to grow, right? Because it will grow as the kite moves on. So let's label that S. So let's find ds dt, and they give me the information when 500 feet of string has been let out. So when S is 500. All right, looks like I need an equation. So I've drawn kind of a messy graph here. So I've got this distance x up here, this string, right? So string is kind of flying with the kite, and then this distance of 300, right, that the kite is above the ground. So this fixed distance of 300, one fixed number in the picture, this x as the kite is moving out, and this string here. So I see Pythagorean theorem again. So s squared is equal to x squared plus 300 squared. So I have all four pieces of the puzzle that I need. So now I'm ready to take the derivative. 2s ds dt, 2x dx dt, and the derivative of 300 squared is 0. So the 2's go away. So let me bring it up here. All right, so I have s is 500. ds dt is what I'm trying to find. X I don't know, and I know that dx dt is 25. All right, so now is the time to use my when information back into my equation to find out what the x is equal to. So I have 500 squared is equal to x squared plus 300 squared, and I can see this is a 3, 4, 5 triangle, so x squared is 400, x would be 20, so I put that in. So ds dt is 20 times 25 over 500, and it's positive, and that's good because the s is growing, right? The length of the string is growing as the kite is moving on out. All right. Do one more. So we've got a boat being pulled towards a dock. So here's the boat in the water. Here's the dock. And here's some rope that's pulling the boat in. Okay, so the ring on the dock is 5 feet above the bow of the boat. So this distance here would be 5 feet. The rope is being hauled in at this rate. So let's label this R for rope. So dr over dt is coming in at 1/2 foot per second. Okay, so let's think about it. Is that length R getting smaller as the boat is moving in? It is. So it's necessary for you to give that a negative length. How fast is the bow of the boat approaching the dock? So this distance here, we know the boat's coming in, so let's give this B. So find dB dt. All right, so I've got my given rate, my find rate. What's my when information? How fast is the bow of the boat approaching the dock when 10 feet of rope is let out? So when the 10 feet, when R is equal to 10, and then I need to put the pieces together to find an equation. I do believe it's triangle again. So r squared is equal to b squared plus 5 squared. I am ready to go. So 2r dr dt, 2b db dt, and derivative of 5 squared is 0. Cancel the 2's, so I've got r is 10, dr dt is negative 1/2, b db dt. Okay, so now it's time for me to use the r equal 10 to go find out what b is equal to. So I'm going to put the 10 in for r, b squared plus 25, so I have 100 minus 25, so 75 is b squared. So because it's a distance, I'm going to use the positive. So I get a negative 5 over root 75 is db dt.